All right, so let's get going on part 3 of today's class. So just the way that it kind of worked out in the schedule, we are encountering all 3 different t-tests today in this meeting. So we are now going to start up on chapter 9, which is the t-test now for independent means. So we just saw the t-test for dependent means. Now we're going to see the sister test, the t-test for independent means. And one very classic psychology study that was tested with the independent means t-test was a study by the memory study, Loftus and Palmer. Almost got completely ironic there. So it was a study by Loftus and Palmer, and what they found was that for eyewitnesses to a car crash, their memory, so that person's memory for what they witnessed, can be highly influenced by how the questions are asked. So if you ask a person, how fast were these 2 cars going when they hit each other, you will get different estimates of speed. They will remember it differently than if you ask them, how fast were these cars going when they smashed into each other. So this was a very crucial study in psychology that showed us that our memory is not hardwired. It's actually very malleable, and you can actually, you will actually change, not your opinion of things, but your actual memory of things, depending upon how people ask a particular question. So we're going to take a look at the hypothesis testing procedure that Loftus and Palmer used in their study in order to have the hypothesis test for this very groundbreaking piece of research. So we're going to just very briefly mention about one-tailed versus two-tailed hypotheses, because so far we've been using two-tailed. I just want to make you aware of how to do one-tailed in SPSS. Now we're going to take a look at hypothesis testing with the independent means t-test, and we'll do that in SPSS as well. We'll have some time for extra practice, and I'll just mention about your homework as well. So when you are doing your hypothesis test, we've already seen how to do one-tailed tests with cutoff scores and sample t-values, right? So we've already seen that. You draw your one tail, you find out if your sample has crossed over into the tail. That's with cutoff scores when you're doing it in that way. We're trying to move towards a complete ability to do hypothesis testing just with SPSS, where we don't have to resort to flipping to that appendix. Because of that, we're moving towards using probabilities for your sample, your p-value, and cutoff probabilities for your sample, your alpha level. And if your probability for your sample is less than your alpha level, you accept the research hypothesis and reject the null hypothesis. If, on the other hand, the opposite is true, the probability of your sample, your p-value, is greater than your alpha level, well, we saw that here, that ties into accepting the null hypothesis and rejecting the research hypothesis. Now, one thing about SPSS, though, is that when it calculates your probability for your sample, it calculates the probability two-tailed. So when it calculates that probability, you'll see right here, it'll let you know that's a two-tailed probability. That's the probability of your sample either being that big or being that small, right? What's the probability that a difference would be that huge, either positively or negatively? That's what that two-tail analysis means. So that's great if you're doing a two-tailed test, because you can just take your p-value, your two-tailed value, compared to your two-tailed alpha, and reject, in this case, reject your null hypothesis. So that was what we've been doing so far. That's straight. That's done straight. That's for your two-tailed test. But what do you do if you only have a one-tailed test? If you want to do a one-tailed test, what do you do with your sample probability? So in that case, let me just get rid of this here because I want you to see this nice and big. So if you have two tails for your comparison distribution, right? So that is half of your alpha, alpha divided by 2. That is half of your alpha, alpha divided by 2. And SPSS figures out where your sample is, your sample's probability on that comparison distribution, and that's your sample's probability on the positive side, and that's your sample's probability on the negative side. That is what that p-value is. That p-value, back it up. That p-value is your sample's probability on one side plus your sample's probability on the other side. Just the same way that your alpha value is your probability on one side plus your probability on the other side. So it makes sense to compare two-tailed cutoff probabilities to two-tailed sample probabilities, right? It's fair. Two tails to two tails. That's a fair comparison. What if you're doing a one-tailed hypothesis? Well, there's nowhere to tell SPSS to do a one-tail. You can't let it, it won't do that. It'll always give you two-tailed. So what you need to do is you need to make this a fair comparison. So if you have a one-tailed test, all of your alpha goes into one tail. So if you have a one-tailed test, you don't have these two tails over here. You only got the one tail, right? And all of your alpha is in the one tail over here. So the key thing here to remember is that you're always comparing it to alpha. Do not touch alpha. Alpha is hands-off alpha, all right? It's a special number. You need more letters after your name before you start messing with alpha. We're not quite there yet. You don't mess with alpha. Alpha stays alpha. Never change alpha. But notice that we have a two-tailed probability here. But we're only interested in one tail. That's all that we want. So here we're doing this unfairly. We're comparing a two-tailed probability to a one-tailed cutoff probability. That's not fair. Two tails over here, one tail over here. That's not right. So what we need to do is we need to take our p-value and we need to get rid of one of those tails. SPSS will not do that for you. We got to do that on our own. And to get rid of one of the tails, all you do is you take that probability and you divide it by 2. So you take your sample's probability, which SPSS will give you as 2 tails, and you say, thank you very much, SPSS, but I only need half of that. I only need the one tail. So you divide that by 2, and now you compare one tail of your sample probability to one tail of your comparison probability. That's a fair comparison. So when you're doing a one-tailed test and you're using the probabilities, leave the alpha alone. Do not mess with alpha. Alpha's alpha. It gets the first letter in the alphabet because it's hands-off. But your p-value, SPSS will always give you 2 tails. If you're doing 2 tails, fine and dandy. You just go right ahead. If you're doing a one tail, you take the 2-tail probability and you throw away one of the tails by dividing by 2, and that gives you your probability for analysis. When you're starting to do this in this manner, I would highly suggest check your conclusions to your cutoff scores. You should get exactly the same conclusion. That'll let you know that you're doing both of those correctly. Probability, again, for your sample, if it's always going to be given to you as 2-tailed. If that's what you're doing, read it straight off of SPSS. If you're doing a one-tailed test, take that 2-tailed calculation, chop it in half, throw away one of the tails, and now you have a fair comparison. All right, so that's just my forewarning or bringing attention to that you can do a one-tailed test straight off of SPSS. Just take your p-value, your sample's probability, chop it in 2 to get rid of that extra tail that you don't need. All right. So what we're going to do right now is we're going to do an independent means t-test to round out our look at t-tests. So let's take a look at the description. So in 1974, Loftus and Palmer conducted a classic study demonstrating how the language used to ask a question can influence eyewitness memory. Incidentally, the Harlow and Zimmerman paper, the adult timeout paper, and this classic paper are available for you in Canvas. So if you have an interest in these areas, highly recommend at some point take a look at those classic papers, see what they actually did, because they are often reported in textbooks and they're often reported incorrectly. So always go to that source material. All right. Back to the question at hand. In the study, college students watched a film of an automobile accident and then were asked questions about what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed to hit instead of smashed into. The smashed into group reported significantly higher estimates of speed than the hit groups. Suppose a researcher repeats this study with a sample of today's college students and obtains the following results. So we have these results here. 15 subjects in the smashed into group, they gave an average estimate of 40.8 miles an hour. 10 subjects in the hit group, they gave an average estimate of 34 miles an hour. And these two groups are completely different people. And that is because, you'll learn more about this in Methods in Experimental Psychology, that is because this experiment has massive carryover effects, and you cannot measure people twice on this experiment. So if I walk up to you and I say, can you be part of my experiment? And you're like, sure. And I show you a video and I say, how fast were those cars going when they hit each other? You would say, I don't know, 35 miles an hour. And you would think nothing is weird. If you started in that experiment, right, you didn't see it, another subject comes into that experiment, and I show them a video and I say, how fast were these cars going when they smashed into each other? No problem. They would take a look at the video and they would say, yeah, I don't know, 40 miles an hour. If you take one subject, show them a video, and ask them, how fast were these cars going when they smashed into each other, and they give you a number, and you then ask them again, now tell me how fast were they going when they hit each other, they're going to know something's up. They're probably going to think that you're a little confused because you're basically asking them the same number twice, right? So they're going to be a little weirded out. They're not going to give you accurate information. You can't measure people twice in this situation. So dependent means is gone. We need to have independent means. Half of the subjects, one group of subjects ask how fast were they going when they smashed into each other. A separate group of subjects ask how fast were they going when they hit each other. Two independent groups, we have an independent means t-test. All right, so in this case, what we have is we have two different populations. We have the hit population over here. We got the smashed into population over there. And we're asking, are they really two different populations? So we get one sample from the hit population. We get another sample from the smashed into population. And we ask ourselves, is this sample from the smashed into population different enough than this sample from the hit population so that they really belong to the same population, right? Is it big enough so that the two populations are different, or is the difference small enough so that they're basically part of the same population? All right, so in this case, we have the two independent means t-test. So it's as if we take two samples. This is another way to think of it. We take two samples from the same population. Only one of them gets treated, and then we see if that treated sample actually has changed into this new population. Has our treatment changed our sample from our our original population enough so that it now belongs to a new treated population? One place where independent means tests are often used would be in drug studies that include a placebo condition. So if you wanted to know, is your drug more effective than a placebo, then you would give one sample from your population, the placebo, one sample from your population, the treatment, and you would see if your treated sample changes enough to belong to a new population. All right. So we're going to be comparing this treated sample to this untreated sample over here, or differently treated sample, whatever the experiment requires. Okay, so let's take a look at our experiment here. So those are the raw scores right there. So once again, in SPSS, you need to have the raw scores. You have to have the raw scores for each individual subject. And we can see here that we have subject number 1 in the smashed into condition estimating 43.13 miles an hour. Subject number 2, 45.46 miles an hour. Subject 15, 33.11 miles per hour. Those 15 subjects are in the smashed into group. These 10 subjects over here are 10 new, completely different subjects. So in total, we got 25 subjects in this experiment. 15 in one condition, 10 in the other condition. Importantly, this subject number 1 in the smashed into group is not this subject number 1 in the hit group. Two completely different individuals. All right, so let's get going on the hypothesis test. Using a t-test with independent means. So once again, new t-test, same hypothesis testing procedure, same 5-step procedure that we've always been using. So once again, let's go to the null and research hypothesis. So we want to restate the research question as a null and research hypothesis about the population. So once again, we're doing a two-tailed test here. We want to know, is there a difference in the speed estimates between the smashed into and the hit groups? So our research hypothesis is that there is a difference in the speed estimates. So the mean estimates for the smashed into population does not equal the mean estimates for the hit population. So this is the two-tailed difference. So maybe the smashed into population is higher, in which case it wouldn't be equal. Maybe the hit population is higher, in which case it wouldn't be equal. Either way, there's an effect. That's the research hypothesis. Null hypothesis is that there is no difference in the speed estimates. And that is written as the mean of the smashed into population is the same as the mean estimates for the hit population. They both estimate the same speed. So that's the same null and research hypothesis that we've been seeing for a while. Null hypothesis, there is no difference. Research hypothesis, yes, there is a difference. All right, determine the characteristics of the comparison distribution. SPSS will do this again for you. So for the independent means t-test, SPSS will calculate your distribution characteristics for you. Set a cutoff sample score or critical value, SPSS won't do that for you. So we're going to start moving away from that, continue our use of cutoff probabilities. So now instead of a cutoff score, we're going to use a cutoff probability. And that cutoff probability is your alpha level. It is your alpha level. So your cutoff probability, the line in the sand, the number that you are going to compare your results to is that alpha value. And in this case, it was given to you in the question, alpha of 0.05. So I'm going to show you, we're going to do this whole test without going to the table, without finding the critical value. We're going to do it by comparing. Instead of the cutoff score, we're going to compare it to the cutoff probability. Alpha is your cutoff probability. And what could be easier than just looking at your question and saying, what's alpha? Alpha's 0.05. So we're going to make it easy on ourselves and do it this way. Determine your sample's score on the comparison distribution. SPSS will do that for you. But again, we're moving towards not scores, but probabilities. So we want to compute our sample's probability on the comparison distribution, and SPSS will do that. And that is known as your p-value, and SPSS will calculate that for us. All right, so now it's time to do some actual calculations. So if you haven't already, open up that third Excel sheet for today, Excel sheet 08C, practice June 10th, chapter 10. And the one that you are looking for is this one right here, and we are going to be doing the eyewitness memory data. So just let me zoom in on that. And there we go. All right. So here's our eyewitness data. We need to, first thing, get this into SPSS. So our first move is going to be to take our smashed into group, and we are going to copy their data, just their data, and then we're going to work with the rest of it in a bit. So you can copy the subject numbers as well, but just to keep it simple, we're just going to copy the data here. So Control C to copy that, and then go to SPSS, and we can just paste that straight in, depending upon the functionality that you got. All right, and we have those scores in there. So let's go to variable view, because we got bar 00004. You probably got another number because SPSS will keep count of how many variables you've been using. But either way, horrible name. So we go to the variable view down here, and we change that, and let's change that to speed, and that will jog our human memories and let us know these are the speed estimates for your experiment here. Okay, so we have the speed here, and this is for the smashed into group. So what we're going to do right now is here in this second column, we are going to label each of these rows, each of these scores as smashed. Smashed, not smashed. All right, so we're going to label each of them as smashed. So you can copy and paste this all the way down, however it is that you like to do it. I think you can also copy, and then highlight the area that you want to paste and paste it all the way down. As you grow more familiar with SPSS, you'll be able to do this. You'll be able to find these shortcuts for yourself as well. But importantly, this is the column that is going to let SPSS know that this is the smashed into group's scores. These are the estimates of speed for the smashed into group. And we are going to go to variable view here, and we're going to call this group so that we don't forget. Question? Yep, this one. Oh, no. This is the problem. This is one here. Oh, sorry. It's in the Excel practice file. Yep. All right, so we label this as smashed. This is what lets SPSS know at this point that those are the scores for the smashed into group. All right. So far, so good? Okay, so now the question becomes, what do we do with the hit group? What do we do with these scores? And we got to copy them, and we got to paste them somewhere in SPSS. Now remember that when we did our dependent means, we pasted them into another column. We pasted our scores into another column because those scores belonged to the same subjects. That we cannot do here, because this column number 1, that is for subject number 1 in the smashed into group. That belongs to nobody else except subject number 1 in the smashed into group. So if we put subject number 2's score right there, we're violating SPSS's organizing principle. SPSS says every single subject gets one row and only one row. So we can't put our scores here in this column because that's going to put 2 subjects in the same row. So what we got to do is we got to move down here and give subject number 1 from the hit group their very own row. And we do that by pasting their data. I forgot the step here. We do that by pasting their data into, in this case, row 16, column number 1. All right, so we paste their data underneath so that each of these subjects in the hit group get their own row. And you'll know you've done this correctly when the number of rows that you have in SPSS equals the number of subjects that you have in your experiment. So we have 15 subjects in one group, we got 10 subjects in another group, 25 total. We got 25 rows in our SPSS experiment. And then the last thing we need to do is we need to tell SPSS what the name of this group is. So we're going to call this the hit group. And you can fill that all the way down. And then we have one column that has all of the speed estimates. We got another column that lets SPSS know whether you're in the hit group or whether you're in the smashed group. All right, so does everybody have that set up? All right, so we have the groups labeled, we got our scores in there, we are ready to go to the analysis. So once again, back to analyze and back to compare means. That's where all our t-tests are. And this time, SPSS is being rather friendly because we want to do an independent means t-test, and they have something called an independent samples t-test. And again, to our human minds, that's the same thing. It is the same thing, nicely labeled this time. Thank you, SPSS. So once again, in analyze, compare means, independent samples t-test. When we click on that, we get our little dialog box here. First thing we want to do, in the test variables, we want to put our raw scores into the test variables. So that's where we get, in this case, our subject responses, our subject scores, our subject's estimates of speed. So we click on speed and we pop that into our test variable. If you make a mistake, again, you can just highlight it and pop it out. And your test variable has to be numbers. And if you try to put this if you try to put your grouping variable in there, it will let you know words are not allowed in that list. So if you get a warning like this, that means that you tried to put words like smashed and hit into an area where you can only put numbers like 43.13. All right, so we'll put speed there into the test variables, and then the group, your words, the names of your groups, that goes down here into the grouping variable. And then when you get down here into the grouping variable, you'll see that SPSS says, all right, you have group, that's where you have the names of your groups. I'm going to give you 2 question marks because I got to know what are the names. What are you calling your 2 groups? So the last thing we need to do is go down here to define groups, and we need to let SPSS know what these groups are called. Now I'm going to do this wrong the first time just so you can see what happens, so don't do this yet. But let's say that I was in a rush and I said, okay, my first group is called Smash. It's not, it's called Smashed. That's wrong. But let's say that I put in Smash instead of Smashed. And my second group is called Hit. So I'm telling SPSS, look for scores associated with the group Smash. Look for scores associated with the group Hit. And then I put OK. And notice that SPSS kind of goes a little off the grid and gives me this message here. Warnings, independent samples table is not produced. And look at my statistics here. Cannot be computed because at least one of the groups is empty. So if your test runs, it'll run it for you. SPSS will not stop you from running the test. But if it comes out and your tables are missing and there's no real data there, your test hasn't actually been run, that means that somewhere along the lines you made a human error, you made a manual error. So that's your clue that something went wrong. So then you go back and you say, well, all right, let me double check this. Analyze, compare means, independent samples t-test. Speed is okay, that's what's supposed to be in there. Group is, oh no, I put Smash instead of Smashed. All right, let me define these correctly. So now you can follow along, you can do this. We need to put Smashed instead of Smash. Last time I did this, it is case dependent. So if it's in uppercase, put it in uppercase. If it's lowercase, put it in lowercase. So we have Smashed right now for group 1. We got Hit for group 2. We hit continue, got them properly defined. We hit OK. And now, very nicely, SPSS has run the test. Now it's done the test that we've asked it to do because we've identified the correct groups. So bear that in mind. It's just a good general principle to keep in mind. SPSS can go wonky on you a lot of times. SPSS might do something that you didn't expect. Most of the times it is on you. It's a human error that we did something incorrect. But all of the time, SPSS will let you know. It will let you know something went wrong. So take that information, go back to your setup, find out what that was, and thank SPSS for the feedback and proceed on with your hypothesis test. All right, so we got the output. Let's analyze it. Let's take a look at what it actually tells us. So once again, we're trying to get down to here, where we're going to decide whether or not to reject the null hypothesis. And if you're using cutoff scores and sample scores, same logic, still works. However, we're moving away from sample scores and cutoff scores into probabilities. So once again, if your p-value, if your sample probability is less than your alpha value, your cutoff probability, then we're going to accept the research hypothesis, we're going to reject the null hypothesis. If, on the other hand, your p-value is greater, your p-value, your sample's probability is greater than your alpha, your cutoff probability, we're going to accept the null hypothesis and we're going to reject the research hypothesis. There's our output. Let's zoom on in and let's take a look at what we do as humans in reading this output. All right, first thing first, we're going to go up here to group statistics. Always go to group statistics. Always double check it. SPSS has very nicely given us information that we gave it 15 subjects in the smashed group, 10 subjects in the hit group. And I cannot tell you how many times students have made errors when they're labeling the groups and they're copying and pasting rather quickly and they go one subject too many. So you end up with one extra subject in one group, one fewer subjects in the other groups. That throws off your entire analysis. So just as a caution, check here and say, all right, yeah, I have 15 subjects in the smashed into group. SPSS found 15 subjects. I got 10 subjects in the hit group. SPSS has 10 subjects. So double check that the numbers of your groups are correct. Double check that the mean score, or the mean of the scores for each group is correct, so you can calculate that in Excel and just compare it right there as well. So use this group statistics table up here to basically double check your input and your analysis. All right, so we've double checked, everything is good. Next thing, determine the characteristics of the comparison distribution. SPSS will do this. So we want to know what is the characteristics of our comparison distribution. Notice SPSS does not give you the mean for your comparison distribution. That's because the mean is 0. So if there is no difference, right, between the two populations, then their difference will be 0, right? If there's no difference, the difference is 0. That's your null hypothesis. That's the mean of your comparison distribution. That's why it's not reported anywhere here. But we do need to find the rest of the information. Standard deviation of your comparison distribution, aka your standard error, and the degrees of freedom. So we go down to this table over here. Importantly, this table you'll see has 2 rows. The one we want is the one that says equal variances assumed. That was an assumption that was made and kind of became incorporated into statistical analyses. It makes the calculations very much simpler. It was used extensively back in the old days of paper and pencil tests, when those poor grad schools were locked in their ivory towers with stacks of paper and their calculator, or their abacus, depending upon how far back you go. But this is the one that is most often used. So if you'll learn more about how to make that decision when you go to grad school. But for right now, just know that we're going to stick in the top row here. So those are the numbers. Where'd they go? Those are the numbers that you're working with. Ignore the second row. Don't go to the second row. Always stay in that top row. That's where we're going to go for this intro to statistics. Later on, like I said, in grad school, you'll find out all about that bottom row when you get there. All right, so we're in that top row. Looking for our comparison distribution. We need degrees of freedom. We need the standard deviation, aka the standard error. Degrees of freedom right there. So we got 23 degrees of freedom for our comparison distribution. Standard deviation right there. So once again, this time we got 4 things that are labeled standard error. We got these 2 up here, and we got these 2 down here. That's the one you're looking for, the standard error of the difference. That number there is what you're looking for. Make a note of where to find it. Again, half of doing SPSS is knowing where to look on that output. So that's your comparison distribution. 23 degrees of freedom, standard deviation of 2.58779. All right, step 3, set your cutoff probability. We don't even need SPSS for this. Our cutoff probability is alpha. That is 0.05. So we are putting into our tails, our cutoff probability, we're putting 5% into our tails. So we got half of alpha in one tail, we got half of alpha in the other tail, and that is 2.5%. All right, so we got 2.5% in each tail for a total of 5%. Next, we determine our sample's probability on the comparison distribution. So again, we're doing this so we can compare our sample's probability directly to its SPSS, it's the alpha level, directly to that probability. So SPSS will do this for you. Now, for your homework, you will need to calculate your sample's t-score. You will need to calculate that value. So just so you know where to do that or how to get that for your homework, SPSS will do that for you. So based on this difference and this standard deviation, that is the information you need for that t-statistic, but you don't even need to use that. You got your t-statistic right there. That is the t-score for your sample, the t-statistic for your sample. That's your sample t-statistic. All right, so that's it right there, 2.628. That 2.628 are these sample, 2.628, these sample scores right there. So that's what that 6.28 means. That's where your sample mean is. Okay, and it's a two-tailed. So that's the sample mean up here or the sample mean down there. What positives were. All right, so that's your sample means right there. We're doing this probability style. The probability of getting a sample this weird with tails that big is that significance level right there. So these two tails combined, right? Those two tails combined equals 1.5%. All right, so those two tails combined equals 1.5%. These two tails combined equals 5%, right? That's our alpha. So those are our cutoff probabilities. This is our samples probability. Notice, comparing two tails to two tails, that's fair. You compare two tails to two tails or one tail to one tail. We're comparing two tails here to two tails over here. That's fair. And notice that our sample score puts it into the tail of our comparison distribution. And notice that our sample score makes its own tail. And that own tail is smaller than the tail of your comparison distribution, smaller than your cutoff tails. So we are comparing tails to tails. And our tail for our sample is smaller than our cutoff tail. So if your p-value, if the probability of your sample's tails, is less than your alpha level, your cutoff tails, then you accept the research hypothesis and you reject the null hypothesis. That's the situation we're in. We're going to accept the research hypothesis. On the other hand, if the opposite was true, if this tail was bigger, the only way that happens is if your sample didn't make it into the tails. So that's why we accept the null hypothesis in that case and we reject the research hypothesis. So as it is, we can just compare directly. 0.015, that's the probability of our sample. 0.05, that is our cutoff probability. 0.015 is less than 0.05. So according to our decision tree, we reject the null hypothesis, we accept the research hypothesis, and as it turns out, the smashed into group did have higher estimates of speed than the hit group. And again, this was a revolutionary study in psychology that showed that our memory is very malleable. And it's not just that we're influenced, it's not just that we're persuaded to give higher estimates of speed. We actually remember higher speed when we're asked questions in a certain way. And this is one of the reasons why it's not allowed to ask leading questions in a trial, because you literally can rewrite the memory of witnesses in that very trial. So they remember things differently just because of the way that you ask the question. All right, that was a lot of t-testing. Okay, so we got 15 minutes, approximately 15 minutes left in class. We're going to have that open for practice time. I just want to point out a few things. So there is some extra practice. Once again, another set of data, another set of PowerPoint questions. So use that extra practice. Get very comfortable doing these t-tests. We've got 3 different ones right now. You are now ready to do your homework assignment for Chapter 9 for the independent means t-test. But I just want you to know that that is going to be due June 14th. So even though you're ready to go and you can do it now, you have your single sample t-test homework to do, your dependent means t-test homework to do. So just to give you a little bit of extra time, this is not due until June 14th at 12:15 p.m. Notice the weird due date because another exam is coming up, and that's why we have that special due date. But importantly, it's not due by next class. So focus on the single sample and the dependent means t-test. If you got some extra time, you can get cracking on it for sure. You got enough skills right now. You have the necessary skills to do that homework. All right, so that was what I wanted to cover for today. So if it's 3 hours is your limit, feel free to call it an early day. If on the other hand you want to stick around, start with some of your practice, maybe start with some of your homework. If you have any questions, call me over, and I'll be more than happy to help you. Other than that, I am done with what I wanted to cover today.